Number 16, it says, let capital F of x be the function defined by f of x's integral from 0 to x, sine of t over t dt. Find the Maclaurin series for the function f and compute its radius of convergence. Find the 20th derivative of f at 0 and the 21st derivative of f at 0. Okay? So parts of this problem are quite typical. The intimidating parts are probably, first of all, this is a function with the integral in it. That's number one. And then these big derivatives. But if you've done some of these problems already, if you followed along in some of my other videos, I always say that these are actually very easy to find, okay? So I'll explain that once more when we get there. But let's tackle this guy first. Whenever you get a function with the integral in it, here's a tip. A lot of times you need fundamental theorem of calculus to help you out, or even to solve it, okay? And that's what we're probably going to do in this case to simplify this guy, to make this problem easier, I should say, not simple, but I guess simplify. Okay, so let's keep that in mind. Now let's go to my PDF of solutions, okay? So I rewrote the question here. So as I said, we might need to use fundamental theorem of calculus. So what if we differentiate both sides? It might be easier to work with something without integral, okay? So if we differentiate the left-hand side, that's just capital F prime. If we differentiate the right-hand side, that's fundamental theorem of calculus, that's sine x over x. Now it's much simpler, okay? We can find the power series representation, the Maclaurin series, for this guy over here, F prime, okay? We can start with sine x. Hopefully we have that memorized. It's this right here, summation as n goes from 0 to infinity, minus 1 to the n, x to 2n plus 1 over 2n plus 1 factorial. I remember it is, first of all, I just remember the expanded form. It's just x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial, so on and so forth. You alternate signs starting with positive, and it's the odd powers, okay? That's how I remember. So that's sine x. So to get from sine x to sine x over x, we just divide by x on both sides. So divide by x on the left-hand side, that's just sine x over x. Divide by x on the right-hand side. Well, we are dividing each term by x. So by properties of exponents, it's x to 2n plus 1 minus 1, because we're dividing by x. So this simplifies to x to 2n. Okay. Now, remember, we can differentiate and integrate power series. So this is the power series representation for f prime. So to get the power series on the Maclaurin series in this case, for f, we just integrate both sides, because integral of sine x over x dx is our f of x, okay? And if we integrate this side, we use the power rule. This minus 1 to n is 2n plus 1 factorial. The constants, leave them alone. They don't depend on x. We're integrating with respect to x, by the way, okay? Not with respect to n, but with respect to x, okay? So these terms with n are just constant. This term has x, though, so we got to do the power rule for this, because x to some constant power, okay? So constant in terms of, it's not dependent on x, okay? Not to get confused. All right, so it's doing the power rule, so x to 2n plus 1 all over 2n plus 1. That's right there, okay? This is our power series, or Maclaurin series for capital F of x, okay? Now it asks us to compute the radius of convergence. How to do that? The ratio test. Let's be very careful with the parentheses, okay? Limit as n goes to infinity of a sub n plus 1 divided by a sub n, okay? There's absolute values in the ratio test. We can ignore this changing minus 1 to the n, changing sign minus 1 to the n, okay? So be careful with parentheses. You would get that for a sub n plus 1, and then times, if we're dividing by a sub n, it's the same thing as multiplying by the reciprocal, so that's what this term is over here, okay? Let's do some algebra to simplify now, okay? This becomes 2n plus 2 plus 1, which is 2n plus 3, okay? And this term and this term, we can subtract powers, so it becomes x squared, right? Right there. And then over here, it's 2n plus 3, okay? And this is 2n plus 3 factorial, okay? So these don't simplify, so those remain, okay? But 2n plus 3 factorial, what is it? It's 2n plus 3 times 2n plus 2 plus 2n, sorry, not plus. Let me start over. 2n plus 3 factorial is 2n plus 3 times 2n plus 2 times 2n plus 1 factorial. Okay, so that's why this 2n plus 1 factorial and that 2n plus 1 factorial that I said would cancel. And we're left with 2n plus 3 and 2n plus 2 still, okay? This x squared does not depend on n. It's a constant. It's like a constant. We move it out in front. We don't know what x is, though, so we keep the absolute values. Even though it's squared, technically we could drop it. But anyway, I kept it there for explanation purposes. And what's left? Well, we have a 2n plus 1 on top. And then if we expand everything out on the bottom, the biggest term would be an cubed. And if we take the limit as n goes to infinity, this cube term would totally dominate, right? So the limit is 0, because it'll be 0 times x, which is 0. Okay, since this limit is 0, what's the radius of convergence? Is it 0? No, that's not the case. Remember what the ratio test says. If the limit is less than 1, it's absolutely convergent. So this series is absolutely convergent. And it converges for all x. It doesn't depend on x at all. Okay, if you remember from doing other problems, you set the result of the limit less than 1 and you solve for x in the inequality, right? Well, this doesn't depend on x at all. So it converges independent of x, which means the radius of convergence is infinite. Okay, so don't get tricked by that. All right, so radius of convergence is infinite. How does that help us answer these two? 20th derivative and 21st derivative? Not quite, but okay. To find the 20th derivative, we need the 20th degree term. Okay. Okay, let's go over this is the Power Series representation, right? So it'll be some constant x to 0 plus some constant x to 1 plus some constant x squared, so on and so forth. So imagine doing the power rule 20 times because we're taking 20 derivatives, okay? So all the terms that are degree of 19 and below will all go to 0 by the time you differentiate 20 times, right? For example, let's take x squared, some constant x squared. You differentiate once, that's, okay, let's just take x squared so I don't have to say constant every time. So x squared, differentiate once, that's 2x. Differentiate another time, that's 2. Differentiate a third time, that's 0. So this is the x squared term, right? If we differentiate 3 times, it's 0. So you can hopefully understand that when we differentiate 20 times, the 19th degree term, x to the 19th, and everything below, x to the 19th, so x to 18th, x to 17th, so on and so forth, those will have all gone to 0 already by taking 20 derivatives, okay? And then when we plug in x is equal to 0, okay, this 0 is the center of this power series. This is the Maclaurin series, right? It's the center. When we plug in at the center, look, it'll be 0 to who cares what power? It's not 0, okay? It's not 0 to 0. We would have a problem if that's the case, but it's 0 to some power that's greater than 0. So 0 times who cares what those other terms are? As long as it's not 0 divided by 0 on the bottom, which we aren't, it's 0 as well, okay? So the only term that is left is the 20th degree term because when we differentiate 20 times, so x to the 20th, imagine that, okay? Differentiate 20 times, we would still have the constant, some constants, okay? But the 20th degree term in this case doesn't occur. So we'll see it for the 21st term, okay? So let's just understand that when there's no 20th degree term, because x to 2n plus 1, those are all odd powered terms, okay? All odd powers, I should say. That makes sense. So there's no 20th degree term, so it's 0. Just imagine differentiating 20 times. It's 0 because everything below 20 is 0. It goes away from differentiation. Everything above the 20th degree term is 0 because 0 is the center, okay? And then there's no 20th degree term, so it's 0. The 21st degree term, this is where there will be some constants though. But imagine also doing the power rule 21 times. So there'll be a 21 factorial as well. So hopefully you see that or can visualize that. So we need the 21st degree term, which occurs at n is equal to 10. Okay, because when n is 10, we get 20 plus 1, right? Which is x to 21st power, which is what we want. Okay, so n is 10. So minus 1 to the 10th, that's going to be positive 1. And then we have 21 times 21 factorial on the bottom, right? Okay, so this is the coefficient that's already out in front of the 21st degree term. Okay, and then we have the 21 factorial from, as I said, doing the power rule 21 times. Okay, because x to 21 would be 21 x to the 20th, 21 times 20 times x to the 19th, 21 times 20 times 19 times x to the 18th. So you can see where that 21 factorial comes from. And this is the original constant that's out in front. Okay, so if you simplify, it's 1 over 21. Okay, so all that explanation to hopefully convince you that these are actually quite simple. If we have this simple understanding that we only care about that degree term. If we take the 20th derivative, we only care about the 20th degree term. 21st derivative, we only care about the 21st degree term. Okay, everything that's lower in degree will be 0 because of differentiation. Everything above the degree term will be 0 because it's the center of the power series. Okay, and the actual value is the original coefficient out in front, and then the factorial matching the number of derivatives you take. So this is why these problems are honestly a piece of cake if we understand this simple concept. All right. Hopefully this is helpful. I explained this multiple times before. If you're watching, haven't seen this before, hopefully I explained it. I tried to the best of my ability. All right. Please give this video a like if you found it helpful in any way. And hopefully I'll see you in another video as well. Bye.